So when we created our alignments, we now need to create our alignment density map, the final map that we will use to delineate groundwater area. So I will open Arc Toolbox. So initially, you should remember that this your alignment feature class that you just created doesn't have coordinate reference system. So in order to give coordinate reference system, go to data management tools, projections and transformations, and find this tool, define projection, choose alignment, and go to these layers, or you can find from projected coordinate system. I can find from layers because I added my study area. So this is my study area coordinate system. So now I can open properties again. So it has coordinate reference system, and now it's time to create a density map. So go to spatial analysis tools, open this density tool set, and find line density. So find alignment, and output cell size I will change to 30 meters, and the search radius is this one. You can leave it optional. Let's just read initially. The search radius within which to calculate density units are based on the linear unit of the projection of the output spatial reference. For example, if the units are in meters, to include all features within a 1 mile neighborhood, set the search radius equal to this one, 1 mile. The default is the shortest of the width or height of the output extent in the input spatial reference divided by 30. So we can change, for instance, change it to 1000, right? It will be 1 kilometer, or you can just reduce it. We will go see the results and find out which one is the best option. Anyways, output cell size will be the same. Area units will be I prefer meters, square meters, and click OK. So now it's called computing line statistics. By the way, I forgot to change while creating alignment. Let's again choose 30. One, we can leave 10,000. Okay, and meters, and please don't forget to change the environmental settings. Go to processing extent and choose this extent, same as study area UTM, and in raster analysis choose a mask as again study area UTM. So please change these settings, processing extent and mask, to your study area extent and mask, otherwise it will create some just a quadrant map. So click OK. Now it's creating. So my map is finished, and we can see that it totally falls to the shape and mask of my study area. So I can drop, see that it falls to my study area. And this is my alignment map. So these are the areas which have potentially groundwater areas because they're very close to alignments. You can change the line density to, for a cell size will leave the same. We can change it to 1000, right? And in meters, Please don't forget to change the location. Click OK. Now it's computing faster. Again, I forgot to change the mask and extend. See that what happens when you don't change the mask and extend. It creates just a quadrant map that it's not appropriate for your study area. So we can reduce this radius, right, to until 1000, or we can just change it to for instance not 1000 and not 10,000, sorry, for instance let's choose 3000 square meters, and don't forget to change the extent snap raster, no, extent study area UTM, and raster analysis. So click OK. See that I think this one even better comparing to this, because see that in this previous alignment density was 10,000, right? 10,000. This one is 3,000. Two large areas are just chose as potential groundwater. I think 3 kilometers is sufficient. Probably, of course, groundwater might exist far from alignments. I cannot say that I'm an expert in geology, and it also depends on your study area. Please bear this in mind, but I think that 3,000 is sufficient, or probably you can increase it until 5,000 in case you didn't save it in your study area. So I saved it in my folder. No, yeah, it's in database. Let's save it in my folder. So alignment 3000. You can choose several options and apply to your study area, 3,000, 5,000, 10,000, and see the results. And of course, it's good if you have wells in order to validate your research. So I chose 3,000 radius. Save. Now my alignment density map is ready. Yes. So this is my alignment density map. And the last thing, I need to reclassify it. So high values have high density and low values have low density. So therefore high values will have high potential groundwater potential zones and low influence. So go to data spatial analysis tools, reclassify. Let's choose my alignment. Go to classify. So see that it has 9 classes. I don't think that I need so much classes. I will reduce it until 6. So I will leave it natural to natural breaks. So now I will change it to manual. So the first one will be 0, right? And the other ones will have higher values. So these are high density, lower, and this one is no density. So reclass density .tif. Okay. Hey guys, if you liked the video, please consider supporting the channel by purchasing online courses via my Udemy's profile, GIS Lab. Here you can find multiple courses regarding GIS remote sensing. The link to the profile is below.